Hey guys, welcome to the third video in my new series, Tetris in Python. If you haven't already looked at the first two videos, I'll post a link in the description and you can check that out. So in this video, we'll be covering getting the shapes in Tetris to actually stop moving once they hit the bottom, and deleting the lines once a line has been completely filled up, and adding different shapes, or getting the different shapes to appear in Tetris. So now that we have a shape moving down the screen, let's actually get it to stop once it falls, or gets to the bottom, or gets to something that it can't hit. Can't move past. So let's create a can move function with two parameters, move x and move y. And then let's get the global position, global everything again. And then let's get the current shape, which is shape equals shapes, shape index. And then go over the first rotation of each shape. And then let's set the x, shape, the iteration of the rotation of the shape, and every one square inside it. So set the move, set it to the position plus the next position. So move x and move y will be the next position that we want the square to move to, because we want to check if it can move to the next position. So this function will actually return a boolean. And if y, and actually let's do the same thing for y. Shape I1 plus position y plus move y. And now if the matrix x and y is greater than 0, which means it's not a empty square, will return false. But otherwise, will return true. So now we can actually check whether or not the shape can hit the ground, move to the next line. So now let's create another function that actually implements this. Move shape. And it'll also take move x and move y as parameters. So now let's set everything global. We might need it. If can move x and take the move x and move y. Then we'll actually move the shape. Position x equals plus equals move x, and then position y plus equals move y. This should be position, my bad. So now after this, we will return true, and then return false. So if we can't move the shape, we want it to become solid, right? So let's write a function that allows it to become solid. Def make solid, and again global everything. And then let's get the current shape. That should be idx. And for I in range 4, again going over the first every grid in the first rotation, let's set the x equal to shape I. Actually, the code from this will be basically the code from here. So let's just copy that and paste that like that. So for I in range 4, just get the x, and then we'll set the value of the shape to 2. So basically this will make the shape purple. Now you can see if we run it, it does nothing because we did not call the function yet. So now let's update the display. Actually, no, we have to change the move down function. Instead of just changing the position y by 1, we'll move the shape down. So this function will move the shape down, and it will also check whether or not we can move the shape down. So if we can't move the shape down, we'll make it solid, and then we'll set the position of the shape back to the top. So basically creating a new shape, and then position, and then yeah. So basically we'll set it back into the middle and not the top. So for now, let's set the shape index to 0. We'll set this to random value later on, because we will get randomly generated shapes. And we'll also set the rotation index to 0. So basically reset the orientation of the shape. Ooh, looks like there is an error. So now in the make solid function, it looks like, oh no, move x is not defined. Oh, my bad. Why did I use move x? That should be, it should be we shouldn't even have move x in here. My bad. I probably should have checked my copy and paste. Now let's see if it falls and it becomes purple. Boom. Now let's see if this one also works. Okay, now we have a pretty good Tetris working. Now we just need to 1, allow the player to move it with the arrows, and 2, be able to rotate the shape, and actually 3, we have to be able to clear each line. So like if one row gets completely filled up, let's clear that row. So now let's first focus and let us be able to move the shape. So if you remember in the key press, event.keySym returns the key that you pressed. So we can use that. So if event.keySym is left, which is the key code for the left arrow in Python, in tkinter. So we'll move the shape right, left 1, and then down 0. And then if event.keySym is right, however, we'll move the shape right 1 and then still down 0. So now if we run this, we can move the shape with the left arrow. It's kind of unresponsive because it's at a 0.2, but I think it just contributes to the entire 8-bit idea. Again, if you don't like something, you can always change it yourself. And yeah, go build something of your own, not just copy what I'm doing. And try to really understand the code. It's not your code until you understand it. So now we have moving down. That was easy. Let's not do rotation for now. Let's check if each line is full and then delete the line. So to do that, let's put that under make solid. Another function. You might notice that I'm using a lot of functions. I think it's just easier to look at instead of having this huge massive code. And I try to put the functions in a logical order. So again, global everything for y in range, position y, and then position y plus 4. I'll explain this later. If y is greater than n minus 1, then it'll just stop the function. But so basically that means that the line isn't full and shouldn't be full. So but if it isn't, let's set create a variable is full equals true. Now there still might be some it still might not be full, so we're going to check for that. So for x in range, put 1, m minus 1. So we'll check if each column in that, each block in that row is empty. So if any block is empty, we'll set this to false. We'll set is full to false, and then we'll break. And if, but at the end, if is full equals, so basically is full. So if it's full, we'll have another function called delete line, and it will delete the line at position y. So now let's make the delete line function. Delete line. It'll take in the line to delete. So for x in the y position, excluding the sides, left and right sides again, and then this will just get the y of the line, and then we'll set the row to be the row we'll set the row to be the row below it, so that so it'll basically empty all the rows. I'm not sure if I explained that right. I'm not good at explaining things. So if that makes sense, comment in the comments below that it does make sense, and if it doesn't, if anyone watching this can explain it better, please post a comment down below, because I cannot explain things. Yay! So now let's update the move down function. So after we make it solid, let's check if it's full, and if it's full, it'll delete the line. So now let's play it and test it. If I have not made any mistakes, and this is very unlikely, it should give us it should delete both rows that I have just placed down. Dun, 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 dun. Moment of truth, guys. Does this work? No, it does not. We have made an error. I shall now read through this code and see what mistakes we have made. Oh, so the error is in the fact that I'm actually iterating over the tuple 1 n minus 1 instead of that being in a range function. So now if we run that, it should work. Sorry about that. So now you see it. If we run it, it'll delete the 2 lines. I can't believe I forgot that range. So now it'll clear everything like that. So now let's give it random pieces. So from random, import random. This will give us a the random function from the random library will give us a random number from the upper and lower within the upper and lower bound, and including the upper and lower bound. So now, if we can't move the shape, we'll make it solid. Check if it's full. and then set the shape index to a random number between 0 and 3. So now you can see after each time we place a block, it'll be a new block, but we can't rotate it yet. So and yeah, it gives us a nice block to play with, and our Tetris is almost done. Thanks for watching this video, and as always, if you found it useful, remember to leave a like and subscribe, and stay tuned for part 4.